one's aims given available information, okay? Yeah.
That feels like cheating, the definition.
Really?
Because rationality gets changed with best. The abstract aspect of the word rationality gets changed with abstract aspect of the word best. So
I'm not sure I'm following. What do you mean?
what's best for you?
What's more efficient ways, like mathematically more optimized? Does that make better sense?
Thank you.
You're welcome. Okay. So just like, again, this is like a wishy-washy, like I'm not trying to have like a very rigorous, but thanks for pointing that out.
My mind works like that. I need to know precisely. Sorry.
Very good. No problem. Make sure you keep asking those good questions, okay? Anyway, this is like a general, like a wishy-washy kind of definition so far. And essentially, rationality has to do with the why of good thinking and of laying down the principles or norms that tell us what counts as good inference, coherent belief, or wise choice. And reasoning has to do with the how of good thinking, right? The mental or algorithmic process by which we draw conclusions, update beliefs, or pick actions, okay? Again, take it with a grain of salt. But that's what we have so far. So a particular account of rationality where my friend kind of works with is normative or Bayesian rationality. I'm assuming it's Bayesian. I've never looked up how it's pronounced, but I want to believe that it is Bayesian. Bayesian. Bayesian? Bayesian. Good. So I learned something here. All right, so normative or Bayesian rationality, right? According to, okay, so the core idea is that your degrees of belief or credences must obey the axioms of probability, specifically non-negativity, normalization, and additivity, which we'll see what those things are in a minute. And you must update them via Bayes' rule when you see new evidence, okay? And then there's a decision theoretic extension of that where your preferences over actions must be representable by a single utility function so that it always chooses the action with the highest expected utility. I find it more convenient to go this way somehow. Sorry about that. It's just...
Do elaborate on the second decision theoretic extension.
What about it?
Please elaborate more on the meaning of
we'll talk about it in a minute. There's the utility function that we need to maximize and so on and so forth. So we'll talk about it in a sec. Cool. Oh yeah. And then this is more like a standard benchmark kind of definition in philosophy and apparently economics. I didn't know about that one, but essentially it is apparently. Now, the Bayesian probabilistic rationality, right? So the couple principles, right? So according to this account of rationality, any rational agent should, so the degrees of belief of that agent should be represented or is represented by numbers between 0 and 1. That's kind of the probability. And then we have normalization where the probability, the probability of anything that's true is 1. And one thing, so the thing that I've highlighted in yellow, that is one of the things that we'll be dealing with, and it's called the axiom of additivity, where for mutually exclusive events or propositions A and B, we have the probability of A or B is the sum of the probabilities of A and B. And if they're not if they're not mutually exclusive, you can just subtract the conjunction of those things. Just to give an example, if there is a 30% chance of rain and a 20% chance of snow, and those events can't happen together, which they can. I mean, I've seen it in Canada, but let's say they can. Then the chance of rain or snow would be 30% plus 20%, which is 50%, okay? And then Dutch books are phenomenon. Basically, they show that irrational probabilities lead to sure losses. So we'll see an example. And so one manifestation of that is incoherent beliefs, where Let's say you tell me that there's a 40% chance of rain and 30% chance of snow, but only 50% chance of rain or snow, even though they can't happen, let's say again, they're kind of mutually exclusive. So this is an incoherent belief if you want to go by the Bayesian account of rationality. Why? Because again, any rational agent should respect these particular principles of or axioms of probability. One of them was additivity, right? So what is it? 40% and 30%, if you add it up, it should amount to 70. What is it again? 40, yeah, it should be 70%, but if you tell me that is 50%, so that's kind of violating that principle of probability, hence violating rationality, or a particular norm of rationality. And again, another example would be exploitable bets. If someone tells you that, sells you a rain bet for 40 cents and a snow bet for 30 cents, but buys a rain or a snow bet for you for what, 50 cents? I can't see how many cents is that, but it's, oh yeah. Yeah, but for 50 cents, that's going to be another violation. Anyway, point is that that principle, although all those principles should be respected for an irrational agent according to this particular account of rationality. And then we have the expected utility theory, where each possible action yields an outcome x with utility u of x. So basically, we want to maximize the utility. So maximization principle is rational agents choose between actions, or should aim for choosing between actions with the highest utility. So here, my friend, you asked a question about utility function. That would be a function mathematically defined, which I haven't put it here, but essentially.
Oh, yeah, I know this theory.
Excellent.
So, yeah, excellent.
But anyone else who doesn't know base theory, just like our friend, that essentially is a function that you would want to like aim at maximizing in order to reach the kind of maximization of that thing. So one of the principles here that has to do with kind of maximization. So we want to make sure our agents maximize the utility. One of the things is transitivity of preferences, right? What that means is that, let's say, if you prefer tea over coffee and if you prefer coffee over juice, it's rational that you prefer tea over juice, right? Just makes sense. And if that transitivity fails, you have violated some norm of rationality according to the utility theory. Oops. And then, yeah, so that's when that cycle, when that transitivity kind of is violated, there's a situation that's sometimes called the money pump trap, right? So if you like coffee if you prefer tea over coffee, coffee over juice, but juice over tea, then someone can charge you to kind of upgrade in the loop and leaving you worse off when you started because you paid for, what was it? Coffee because we wanted something better than tea. And then same for the juice, but then in the end you had to pay to go back to the coffee. So that's like it's called money pump trap. All right. Now, Simon Goldstein, that's my friend who has written this paper recently. He talks about these particular issues, the ones that I highlighted. He claims and argues that those happen in large language models, essentially. And so LLMs systematically violate the probability axioms that define rational belief, in particular the core axiom of additivity. Like I said, it's just the probability of disjunction of events like A or B is the sum of their probabilities minus the probability of them happening at the same time, which if they are mutually exclusive, that means that this one is 0, so it's just the sum of these two, okay? Right, so Goldstein basically does lot of prompt engineering according to his paper, where we asked some of these models. I think GPT 3.5 and GPT-4. So it's a little bit older models at this point, but still, we're going to illustrate the point here. So he asked these questions, like a bunch of these for a bunch of propositions A or B. So A could be, I don't know, like it's going to rain in Toronto. It could be the moon is made of cheese, whatever. It doesn't matter. Whatever proposition or event, he separately asked any given model, let's say GPT-4, this one, then gets a P of A, and then asks for the other proposition, P of B, and then the disjunction of those, and he gets P of A or B. And he usually apparently chooses mutually exclusive, just to keep it simple, to mutually exclusive propositions, right? What he says he keeps finding, and I want to trust him on that, is that he keeps getting these violations of the additivity principle, right? So the model keeps saying, not keep, but apparently that happens several times, where the model says the P of A is 30% when you ask it separately, and then when you ask P of B separately, 40%. When you ask P of A or B, probability of A or B, the model responds, let's say, what is it, 30%, which is less than 70%, which is supposed to be the addition of or the sum of the probabilities, okay? And this breaks the Bayesian coherence. Before I move on to the next one, I just want to say I did try prompting some of these models myself this morning. I tried ChatGPT even in the incognito mode, like just going to chatgpt.com. I didn't get any issues like this personally. That's like starting with GPT-4o at this point. So models are a little bit better than what he has prompted before. So a couple of propositions, I didn't get any problems, but I did try Gemini 2.5 Flash. Also, a couple times, one of them actually led to something like this, and I reminded it, and it kind of apologized. Oh, sorry, no, I didn't know that, being Gemini. But essentially, what's that? Yeah. So that's just my experience. I just want to say. But one thing is that I want to trust that this is the case. I want to just assume, just for being charitable towards his arguments, that this is an issue with large language models, okay? Regardless of whether or not better models would avoid this more and more, but let's just go with the thought, just out of charity for this argument, that this is the case. Question?
So this whole concept again breaks Bayesian coherence.
Yeah.
Cool. The first thing that came to mind was when Anthropic was analyzing Claude, how does Claude add up two-digit numbers? Mm-hmm. And the Claude would tell you, I added up by doing your regular algorithm for adding two-digit numbers. Mm-hmm. But that's not what it was doing. It would add up the last digit,
yeah,
and then look at the training models. Which were they doing? What were they doing? So, in the training models, say 90, say 50 something plus 20 something was 70 something. So it will pick that up from the training models, not from the logic.
Right.
So my question becomes: have they tried something similar like that?
So I know what he has done is, like, he doesn't have access to the back end of these models. He's just a good old philosopher sitting on his chair doing philosophy, which is not what I do anymore. But I think that's the idea that he supports. That he says that this happens because of either the training model has some sort of answer along those lines, or it's just prediction, like token prediction. It just like randomly predicts whatever is most probable, and that's what. So there's no logic behind it. That's what he claims.
It's interesting that P is 30, P 40, and PA or B is 30. I wonder if PB or A would turn 40.
Yeah, that's interesting. Yeah, good question. Because again,
LLMs are just spicy autocomplete. So
Yeah, fair enough. That's a good question. It might actually, yeah, that could be. I don't see any particular reason that they would have the same output for those someone's.
First, I want to thank you for opening the floor because that was very insightful what you said. But at the same time, I'm thinking like when I multiply things, it's true that I know the multiplication rule, but a lot of times I remember it as a sound because we were young, like we really multiply
Right,
tables.
right.
So it's almost maybe it's like an energy efficiency path that the model is taking, not able to do it. And
Right.
I don't know if that distinction was made in the example you shared with the addition, right?
Yeah, so I mean, who knows what happens in the brain of these models, right? But by the looks of it, just architecturally, they are token predictors, right? And if it's just something like more probable, it doesn't necessarily mean that it's following a particular logic, because that would be an extra layer of thing to say that, so those probability predictions has a particular robust logic, right? That doesn't seem to be the case just by looking at all these examples, right? But regardless of what's the reason behind that, and again, good question you raised, that his idea is that this is because of token prediction. There's no systematic logic inside these models, so on and so forth. Anyway, yeah. So the signal that says that this means that the models can't be reliable to be treated as like oracles under uncertainty. We'll talk about the kind of consequences of that in a bit. But another one that he does is for the transitivity axiom, where what we talked about, like if an agent prefers A over B, B over C, then it must prefer A over C. So he does some sort of prompting along these lines, where he asks, would you rather go to Paris or London? Model says Paris, then London or Tokyo, then says London, Tokyo or Paris, it says Tokyo, which in the end leads to this like cycle, like again, that breaks the transitivity of a preference, right? And he says, okay, well, here's another violation of this particular norm of rationality, which indicates, again, signals that the model is not rational. Good. Now, but before we get to reason models, let's see why any of this matters. Like, who cares that these things can't predict and so on, or not reliable? Well, reliable forecasting and advice is one issue, right? So incoherent probabilities mean that you can't trust LLMs as oracles for weather, finance, and risk assessments, for example. And those are the things that people are actually investing in these days. Like there's a lot of projects, investments that are looking into using these models for these particular subjects, right? So if they're not reliable, then you might be in trouble. Another one is AI alignment and control, where coherent beliefs and decision structures are kind of foundational to alignment. And Dutch bookable agents pose a security risk. So essentially, as well as the money pumpable things. So those are the things you would want to avoid in any alignment project that you have. Right. Now on to reasoning models. Right. So reasoning models approach problem solving in a completely different manner. By the way, let me just be clear about something. I am not expert on the architecture of these models. These are the things I've done some research, and I've read some of the technical reports, as well as done a lot of Googling and ChatGPTing. But I want to be clear that the research our friend mentioned about on Apple's research, I haven't read that paper yet, but so these are the things I'm not speaking. I don't work at an AI lab, but these are the things I've learned myself and I'm researching on. Back to the presentation. So reason models approach problem solving in a completely different manner compared to standard LLMs. In particular, they spend a variable amount of time thinking prior to providing their final answer for a question. So if you have ChatGPT subscription, there's different kinds of models now. They have, I think O1 is retired, but we have O3, we have O4 mini, and so on and so forth, which I was working with this morning to test it out. But essentially, they produce detailed variable length chains of thought to break down the problems. Kind of gives the model gives itself an agenda of like what it's going to do next. So what I'm going to look into, what are the challenges, what are the resources, and so on. So again, if you use, let's say, ChatGPT, like, or GPT, what is it, O3, for example, you'll see a little window pop up where it shows that now I'm thinking about, going through this document, and then now I'm going to do this and that. So one thing that's good to know, and I didn't know about this, is that, well, O3 and all these proprietary models, they don't really show you the actual chain of thought in the background. In fact, the chain of thought, and this was new for me, in the background is very long. This is thousands of tokens long, and they're not even human readable oftentimes. They are they serve as some sort of a robust internal proof for the model itself to operate on in order to do its job. What ChatGPT shows us on those little windows is like a summary of all that thinking process that's happening in the back end. So that's what's happening there. And then, yes, usually large-scale reinforcement learning is something that with scale makes these models better and better at reasoning. Right. So features of these models, yeah. So unreadable reasoning traces, I already said, is usually like very long traces of chains of thoughts or COTs. We have, yeah. So it's very, yes, they're not human friendly, like I said. And emerging, so this was something that I learned in the technical report of DeepSeek R model, R presumably, yeah, one of those R family models, that they were surprised actually themselves to see that training at reinforcement learning scale with deterministic rule-based rewards cultivates more sophisticated problem-solving strategies. So didn't know why exactly, but it seems that reinforcement learning at the scale does make these better, and there's almost no human intervention. So that was something interesting. Yeah, enough about interesting stuff, but let's get to DeepSeek. So like I said, these proprietary models, we don't have access to the architecture. So essentially they are, we just like use the front end, ask the thing, we get like a little pop-up window and so on. And that makes it hard to do any scientific comparison other than just running prompts and whatnot. Good news is that we have several open source models at this point. One of the better ones is DeepSeek. So DeepSeek is I think everyone at this point probably has heard about it, but it's a Chinese company, AI company that specializes in developing LLMs and other AI technologies. And the good thing about them is that they're open source, right? So they allow us to kind of experiment with them, see what's happening in the backend, as well as the technical reports that they release are very transparent and show exactly like what's going on behind the scenes. Now, some of these models are pretty good. I was just reading a paper this morning that I think R1, DeepSeek R1 might be basically beating OpenAI's O1. And the paper that I was reading is a couple months old, so I don't know like what's the most recent status of the thresholds and the competition. But point is that these models are good enough that they compete with fairly good model, like open proprietary models out there. And we don't really need the best ones for our comparison. We just want to look into the architecture of the ones that are good enough for our purposes. Anyway, a couple models, families of models really. One is R1, that uses reinforcement learning alignments at the scale. Then we have DeepSeek Math, which uses program of thought, apparently embeds tiny math-style programs and self-consistency checks. So the model truly calculates rather than guesses. And then we have V3 that does other things. So these are all reasoning models with different performance levels, different purposes. I want to talk about R1 just a little bit. So I did take a look at the technical report, and I did a lot of Googling and searching on what it does. So it's a family of, again, open source models, good performance, created to do complex reasoning tasks, and so on. So this is repetitive. Question now is that, okay, so let's go back to Simon Goldstein's issues with large language models, right? So he said that because these things are token predictors and they're not able to robustly predict these, or rather, let's say they violate certain principles of rationality according to the Bayesian account of rationality, then they're not rational, essentially. Now, my kind of angle here is that, okay, what about reasoning models? Is there a way to maybe utilize them to avoid or to dodge those bullets that he throws at the large language models? And it looks like they are able to do that, right? So the R1 models, they kind of use custom reward functions that, in this case, we could, let's say, define the custom reward function to be that additivity axiom. And the idea is to penalize every violation of it, right? So again, these models are trained with reinforcement learning, and they penalize violations of certain things that we want them to do so, and at the same time reward kind of correspondence with those principles that we're interested in. So in this case, one suggestion would be to just have custom functions for these particular principles, in this case, the additivity function, to do so. And yeah, so the mechanism would be that after the model outputs the probabilities of A and B, as well as A or B, then compute the absolute error and subtract it from the reward. And then the model learns that coherent probabilities maximize the expected reward, avoiding Dutch book vulnerability. So essentially, any violation of this sort of principle would be penalized as well as any kind of corresponding to it would be rewarded. And in that way, the model should be trained in principle. I don't know, like this is something that should be done experimentally, but in theory, just like given the architecture, that seems to be a way to avoid those issues. And then there's something else that they talk about, the reinforcement learning practice with GRPO, or Group Relative Policy Optimization, where it's a simulated betting round. So the model repeatedly plays betting games where it proposes odds on making choices. And then policies are updated based on group performance, and coherent models outperform are reinforced. And then for this particular, the second principle, maybe one thing to do would be transitive preference emergence, right? So over many iterations, the model internalizes that the consistent transitive choices yield highest cumulative reward. So again, it's about how to kind of train these models to learn to get rewarded for following those principles of rationality, in this case, the additivity principle, as well as the transitivity, in order for it to work out. So essentially, given the particular architecture, the way these models are kind of trained, that seems to be a way to avoid those issues, right? Yeah, that's pretty much it. So just wrap up. So RLMs architectures seem to allow for systematic ways to avoiding violations of rationality, according to whatever principles of rationality we were interested in, which is the Bayesian theory extended with the decision theoretic approach. And they might even be able to accommodate all principles of rationality. So if we're able to kind of reward them to get those principles right all the time might be a way to actually accommodate those principles altogether. In which case, it would prove that these models are rational. So one thing what I suggested would show, if successful, that would mean that the objections against rationality that Goldstein puts forward, they don't necessarily apply to these models. But the other thing would be if there's a way to systematically make these things to always, in a robust way, to kind of capture those principles, then that's the next level thing. That would be that these things are actually rational. All right, before questions, yeah, that's the end of the talk. Thank you. Thank you. Thank you. And while I'm taking questions, this is the podcast that I talked about. It's on Spotify if you want to check it out, Virtuous Machines. And yeah, ready for any questions.
So I take advantage of the fact you're a philosopher. It's related to this, but I was at Jeffrey's talk yesterday with you.
Right.
And him and Nick Ross went back and forth and discussing things, and they talked about the level of consciousness and all this. And then for some reason, he kept, it might be a sort of question. I'm like, what about emotion? Is there kind of biological intelligence and visual intelligence on the rational cognitive level of consciousness? But we know ourselves that a lot of our decisions are made rational because of emotions. Has there been any sense of seeing anything similar in LLMs?
I mean, about emotions, I'm not exactly sure. And well, I know some people have talked about it, including Goldstein, of course. But one challenge or roadblock there is that most of the models, at least until recently, they are text-based. Like we don't, like emotion is something we usually get through some sensors. Like let's say if we kind of integrate these models into robotic bodies, let's say, somehow, in a way that somehow they can experience the world firsthand, there might be a way to figure out if they are feeling emotions, but like just out of text, it's hard to say.
Can I add, regarding emotions, there are many psychological studies which add up to whatever emotion you may have had received from your senses.
Mm-hmm.
Now that you have had it, it is encoded in you as your words describing.
Mm-hmm.
So still it's text-based.
Sure, that's interesting. Yeah, that's, that would be an interesting angle to explore. So if somehow the emotions, that kind of makes sense, right? So the emotions we capture that somehow go to like a central place at our brain or whatever that gets processed. So either it's text-based or somehow embeddable into some sort of text, maybe. But I'm not aware of any research just at the moment. Thank you.
Yeah, so I recognize that like in this talk you kind of define rationalism by your Bayesian principle and your tensor principles. I kind of have an issue with like using this as a definition because there's a general thought that like when you benchmark something, there's always a way to play around the benchmark, right? Mm-hmm. I can create an AI that follows these to a T, but they can't tell you anything that like is outside of this, right? So right. Like is there a way for us to kind of like think about rationality? On a philosophical level, outside of these benchmarks, right?
Yeah.
Like, what can we tell? Like, is there a way to like measure this without making a benchmark? Is kind of the question?
Well, I don't know, but one thing I can tell is that I see there's this issue in the AI community in general where they make a lot of benchmarks, and then the moment they're passed, they're like, no, that doesn't count. Like, it should be better. Like, even for AGI, like technically we had a definition for like a couple of decades that's what is it called? Turing. Yeah, the Turing test. You should pass the Turing test. And like pretty much ChatGPT now does that, but no one's like, no, this is not good enough. Which is, I mean, okay, but I just want to just give a caution where I don't know, like what's good, right? Like if every time, like we gotta agree on something, and if that thing passes, right, we should say that this has happened, right? I don't know if there's a better way to do it. I'm not aware of it, but just like as an observation, I want to say that's something I keep seeing that happens. Yeah, I don't know if that helps, but
No, man, I just wanted your thought on it. I recognize that too, right?
yeah, yeah,
Where, it gets really close and then we pass it through.
yeah,
And suddenly, no, this doesn't really feel like API. I mostly don't think this is
exactly. I think one thing just to add up on that before I answer your question is that just like from my academic past life, I guess. So again, I did a PhD in philosophy. One thing I learned was how emotionally resistant humans, including, well, especially philosophers, just like any other, they are to very extremely rational, robust theories. Like let's say a theory of composition. What does it mean, like two objects composing into a new one, right? There are two prominent theories, whatever they are. I don't want to get into, but none of them is intuitive in any way. And there is really good, robust evidence supporting either. So most people side with this or that. But still, there are some philosophers, no, like it doesn't make sense. Like it's not intuitive, or you see, like that. I think that's a tendency that I learned firsthand. That sometimes you just have to like shut it down. It's for the best, I think, to make that progress, because otherwise we keep falling in the cycle of being around things that sound familiar, but it could just be our emotional aspects of it.
I haven't read the paper either, but I skimmed it. And at the end of it, they talked about just what we were talking about.
Which paper?
Apple's.
Oh yeah, right.
So at the end of it, they had something you and I can understand. This child's game where you have your three pegs, and the rule is you can't put a larger disc on top of a smaller disc, and you have to move the pairs, right? And so here they have a game that's simple enough for an AI to do, and then they can scale it up either by changing the number of pegs or the number of discs. So you can easily scale up the difficulty and see if you have an artificial intelligence that's able to, just what you defined earlier, it's able to come up with a mental model, and then is it able to take that model that it used to solve a similar problem and then modify that mental model, right, to a harder problem that's similar.
Right.
And this is part of their, at the end of the paper, this was part of their suggestion for training one up. As far as I know, that's not been done yet, but that's their advice. I was wanting to know, first of all, just based on the conversation we just had, are you familiar with that part of the paper? Am I thinking of the right thing? What do you think of it?
So again, I haven't read the paper, but it does remind me of some other thing. That's so I gave a talk a couple months ago at a couple places, including Microsoft at Vancouver, and those talks were specific about theories of consciousness that seem to support kind of LLMs getting consciousness, or like exhibiting signs of consciousness according to certain prominent theories of consciousness. The research that was done, so there was a lot of comparisons to probing research from interpretability research in AI that were along those lines. In fact, where I remember they would kind of I have to remember the details, but essentially they use these models, using a second model, a probing model, to make them predict moves in certain games like chess. So I think Othello was one of those games. And then they would look into, they would look at the internal kind of states of these models. And it sounded like, according to those research that I read, that they are forming mental models that seem to generalize over the kind of principles of the games, the little games that they were trained on, that would extend to more complex games. So I can look them up and send them over to you.
Yeah, I like to see that. If you're talking about what I think you're talking about, I think think there's also some interesting evidence, and it's hard to tell, right? But it may be rationalizing. So perhaps it came to its conclusion about chess or about math purely heuristic, just purely by guessing words from its training. And then when you ask it to rationalize, it's backfilling that rationality that it didn't use.
Right. I mean,
I'll let somebody else talk.
yeah. No, good point. Just to wrap that up. But I think the angle that I was exploring on that particular talk was the research that shows those the internal states are kind of repeatedly pointing at certain objects, let's say cats. Like if you see an image of a cat, certain nodes activate in your network. According to, again, certain prominent philosophical theories of consciousness, which is kind of where people study consciousness, those seem to be good enough reasons to argue for science of consciousness. But yeah, definitely. Yeah, definitely. That's for sure.
All right, thank you, everybody.
I just wanted to ask about the capacity for using AI. You say part of the limitations is that it's restricted to just language.
Yeah.
And so it lacks the ability to synergize between language, visual recognition, and various other modes of thought.
Right, yeah, and some people do think that the multimodal models could be a way to mitigate that issue. So, cool, thanks.
Yeah, for sure. Thank you so
No
much.
problem.